tables to graph. A function table has values of x and y. Remember, y can also be written as f of x. They can be used interchangeably. This is just your function notation. Because it's giving you a function rule. And a function rule is really just a fancy way of saying equation. Okay, so in this example here, we have f of x is equal to x squared plus 2x minus 4. This right here is my function rule because that's my equation. So in the function rule, if we substitute in the values for x, we get corresponding y values. And if we have an x and y value, then we have an ordered pair right? An x and a y that we can then use to graph. And like I said, this can be used to graph any type of function. So whether they gave us a linear function, a quadratic function, an exponential function, you can always use a table to graph that function. So here's our table. We have x values. In this particular table, they gave us the x values that they want us to use to find our y values. So we're going to use these x values as our input to get our output. And that's our function rule. So remember, when we're dealing with functions, which is a line, a parabola, and we'll soon learn about exponential functions, all they're really doing is giving us an x, or they're asking us to identify the y when given an x. So it's really simple to figure out the points on the graph, especially if we've been given the x values. So I'm going to go through some examples. So if they gave us here our -3, and what we're going to do with that -3 is plug it into our function rule, our equation, which is x squared plus 2x minus 4. So anywhere I have an x, I'm going to replace that x with the number in my table. So instead of x squared, I'm going to have -3 squared because that's my given x value that they want me to find the y value. So plus 2 times -3, and then minus 4. So -3 squared is going to be 9. 2 times -3 would be -6. And then we have minus 4. And then I'm going to simplify even further. 9 minus 6 is 3 minus 4, which is -1. So when my input or my x value is -3, my y value or my output is -1. One thing I do want you to keep in mind is that when we are simplifying these equations, we must follow the rules of order of operations. We cannot forget that we have to do our order of operations first, meaning parentheses and exponents, then multiplication and division, then addition and subtraction. Because if you don't follow those rules, you're going to end up with the wrong numbers, which are going to give you the wrong outputs. So now all we have to do is take that input of 2 and plug it into our function rule. So we have -2 squared plus 2 times -2 minus 4. Again, all I did was take that input of -2 and plug it in for x so that I can find my y. -2 squared is a positive 4. 2 times negative 2 is a negative 4. And then we're going to subtract 4 more. 4 minus 4 is 0. Minus 4 is equal to negative 4. All right, we have 2 points so far. We have negative 3 and 1, and we have negative 2 and 4. So I'm going to go graph these 2 points. So looking at my graph, I have negative 2 and, negative 3 and negative 1. That's right here, and I can label that negative 3, negative 1. Negative 3 is my x value here on my x-axis. Negative 1 is my y value on my y-axis. Because I didn't actually have you graph for the quiz last week, I don't know if you're able to graph the coordinates correctly or not, but I can tell you that in person, there was numerous mistakes when graphing. Students either went up and down on the y-axis first when it was their x value or vice versa. So make sure you know the difference between your x values and your y values and where they should be on your coordinate plane. So we graphed negative 3, negative 1. Now we need to graph negative 2, negative 4. So negative 2 down to negative 4. I'm going to put my point and I'm going to label it negative 2, negative 4. Okay, now that those 2 points are labeled, I'm going to continue with finding my y values so that I can graph the other points. So my input here is negative 1, so I'm going to do negative 1 squared plus 2 times negative 1 minus 4 is equal to, what's negative 1 squared? 1 minus 2, because 2 times negative 1 is a negative 2, minus 4. 1 minus 2 is negative 1. Minus 4 more is what?
Negative 5.
Negative 5. Another common mistake that I'm noticing among students as a whole is they forget how to add and subtract integers once they have that negative number. They forget that if they have 2 negatives, they're really just adding those numbers together and keeping that negative sign. So make sure that you understand and are thinking about when you have negative 1 and you're taking away 4 more, you're going to end up with a larger negative number. So now I'm going to graph negative 1, negative 5. So negative 1 on my x-axis, negative 5 on my y-axis, and here's my point. And I'm going to label that negative 1, negative 5. All right. That's done. Now we're looking at our input of 0. What's going to happen when we input 0 to for our x?
Anything that's multiplied by the x is going to be 0.
Correct. Thank you. So 0 squared is 0. 2 times 0 is 0. So then minus 4. So I'm just going to end up with negative 4. If my x value is 0 and my y value is negative 4, what is that really telling me? That's my y-intercept. Yep. So this right here is my y-intercept. And that's because that's where my x value is 0. So I'm going to be on the y-axis, and I'm going to be at negative 4. And I can label that as 0, negative 4. Now I made a mistake when I made this worksheet, and I meant to put this as 1 and not 2. So I'm going to go ahead and fill in 1 there instead of 2. And that was my mistake. So let's find out what our output is when our input is 1. So we're going to have 1 squared plus 2 multiplied by 1 minus 4. Well, 1 squared is 1. 2 times 1 is just 2. Minus 4 is equal to 3 minus 4, which is equal to negative 1. So my output is negative 1 when my input is 1. Make sure you change that on your notes so that you don't leave that 2 there. You can still graph that 2, but it wasn't going to give me the symmetrical matching points, so that's why I changed it. So now I can graph my parabola as such. And looking at this table, what do we notice? Where is my vertex? Where is my vertex for this graph?
At -1 and -5.
Yep. This is my vertex. That's my minimum point. So I'm going to highlight that down here and label that as my vertex. And what do we notice in the table that happens on either side of our vertex?
They're symmetrical.
They're symmetrical. So once we find our vertex right here, then we know that the values above and below our vertex should be symmetrical. So we can use that information to help us when we're trying to graph a quadratic function. All right, so I'm going to move on to this next example. But in this example, we have our function rule, but they didn't give us our x values, our input. But how can I figure out what I want to use for my inputs? I'm going to use the axis of symmetry, my formula to find the axis of symmetry, so that I can find the points that I want to do in my table. I also want to consider the numbers on my table based on the graph that I have. So if I have a coordinate plane that only goes from +5 to -5, am I going to try, or from -3, my x-axis from -3 to +7, should I try to plug in an x value of 10?
No.
No, because it's not going to be on my graph. So I'm going to try to pick points for my x values that are going to be on my graph so that I can graph that parabola. All right. So let's start with our axis of symmetry, which is -b divided by 2a. And this is my a term. This is my b term. So what's my c term?
0.
Yep. So that means my c term is going to be 0, which means my y-intercept is also going to be 0. All right. So -x squared. So that's going to be a -1. So 2 times -1. And my b is going to be a -4 because I want the negative b. -4 divided by -2 is equal to 2. So that means that my axis of symmetry is going to be 2. So where do I want to place that in my table? At the top, at the bottom, or in the middle?
In the middle.
Middle.
in the middle. Because I want symmetrical points. And if I want symmetrical points, then that means I have to put my axis of symmetry, the x value for my axis of symmetry, in the middle of my table. Then I can use that axis of symmetry to find my y value, which is going to tell me the vertex. So my equation is negative x squared plus 4x. Now, we have to remember that this negative is being multiplied by that x after the exponent, which is why our order of operations is important here. Because when we write this out and we fill in that 2 for our input, we're going to have a negative 2 squared plus 4 times 2. So with that negative outside the parentheses, it's really just like having a negative 1 multiplied by that 2. And we do that after we do our exponents because our parentheses and exponents are always done first. So that's going to equal negative 1 multiplied by 4 plus 8. So that's just negative 4 plus 8, which is equal to 4. So the vertex I can graph now is at 2, 4. So 2, 1, 2, 3, 4. And I can put my vertex. And I can also do my axis of symmetry now too. So my parabola should be centered on that axis of symmetry. All right. So if our axis of symmetry is going to be at 2, all right, this is our vertex. What other x values do we want to find that are going to be on this graph?
0, 1, 3, and 4.
We're trying. Like, I don't know.
So 0, 1, 3, and 4. Yep, those are all great points. You could do negative 1 and you can do 5 as well. You can choose whatever points you want to graph as long as you have 5. But I just recommend make sure that they're symmetrical. So if you're going 1 up and 1 down, then that's fine. But make sure that you do the same differences for your x values so that you have that symmetry in your table. All right, so if we plug in 0 for our x, what are we really finding?
The Y-intercept.
The y-intercept. Thank you. So this here is going to be my y-intercept, which is why I highlighted it a different color. So negative 0 squared is just going to be 0 plus 4 times 0 is going to be plus 0. So of course it's equal to 0. So the y-intercept is going to be passing through 0, 0, which is the origin. That one was easy. Now let's plug in 1 to our function. We're going to have a negative 1 squared plus 4 multiplied by 1. Well, so that's going to be negative 1 plus 4, which is equal to 3. So that means my output is 3 when my input is 1. So I'm going to go to my graph and I'm going to go to 1, 3 and put my point. Well, I have to go up first. 1, 1, 2, 3. So 1 is my input, 3 is my output. So what do we know now is going to happen? What's going to happen when we plug in our 3?
It should equal 3.
It should equal 3. We can always test it to make sure. So -3 squared is going to be -9 plus 12. Does -9 plus 12 equal 3?
Yes.
Yep. So I can go ahead and put that on my graph. 3 and 3. And so what's going to happen when I have my input of 4?
It should equal 0.
It should be 0. Let's go ahead and check that to make sure. We're going to have a -4 squared plus 4 multiplied by 4. Well, that's going to be a -16 plus 16, which does equal 0. So I can go ahead and graph that point. At 4, my y is 0. And I forgot to label this point. This is at 3, 3. And there's my graph. You can find more points if you want to, but you just need to find a minimum of 5 when you are graphing. Okay, now I want you to work on the practice problems on your own. I'm going to give you a few minutes and then I'm going to come back and check to see how you've done on the axis of symmetry and if you've finished your table. Okay, make sure you're paying close attention to those x values and their y and your y values. When you're using the axis of symmetry, sorry, not your x and y values, but your b term when you're using your formula for their axis of symmetry. Because I've seen a lot of students make errors in finding their axis of symmetry and their vertex just because they have the wrong signs. So I'm going to take a screenshot of this and share it and give you a moment to start the practice problems.